Welcome to the live feed. As promised, here I am. I'm going to do a few little sessions this evening, after school sessions, because this week is your GCSE Physics paper 1. I'm going to go through some questions from this paper, not all the paper, but some questions that I think will be really useful for you. There's loads of things. I'm going to come back after a little while after this one, and I'm going to do some questions from the higher combined science. Okay, so this one is from OCR Gateway Combined Science, and this is the foundation tier. Now, even if you're on the higher tier, there's still going to be some questions that are applicable to you for this one. Even if you're on a different exam board, there's still going to be some questions that are applicable to you. So stick around, okay? It might not be matching yours exactly, but this is still going to be useful stuff. This should only take about 20 minutes to go through it. Also, if you're an A-level student and you're tuning in, well, obviously this is not going to be the thing for you, so I'll catch you later. Can I just have, if you're an A-level student, then at 5 today, Lewis Matheson from A-level Physics Online is going to be live. So I suggest that's what you spend this evening doing, is going through his live feed and contributing to that. I will stop after the multiple choice, and I'll stop then at the end of this paper if you've got any pointers. And afterwards, I'll do a quick Q&A, and at the very end this evening, I'll do a Q&A if there's any bits that you want to me to go through. Not just questions, but any kind of pointers you need from any exam board for this week's exam. Tomorrow, again, I'm going to do some more questions, some GCSE Physics only questions, okay, and so you should stick around for that one. That'll be tomorrow before the exam, which is on Wednesday afternoon. Okay, if you've got ideas for that tomorrow that you want, or if you've got ideas for the end of this one, then you can write in the permanent comments. If you are not subscribed, so you didn't see this, then make sure you do subscribe so you see this one and the other live feeds come in, basically A-level, GCSE. I'll do them just in the run-up to the exams. Right, this first one, what's the typical diameter of an atom? It's just something you need to memorize, okay? And it's this one, times 10 to the minus 10. None of these have got any kind of relevance to it, okay? This is a nanometer, so it's just a little bit smaller than that. Okay, so you need to, that's a fact you need to memorize. A bus takes 1.8 hours to travel 24 kilometers. What's the average speed? You can just give it in kilometers per hour, so it's just about remembering speed is distance divided by time. Plug in the numbers, 24 kilometers, 1.8 hours. People are going to get stuck here because they've been told things like you use meters, you use seconds, but the units are all kilometers per hour. And then that in the calculator, 24 over 1.8, it's just, use that button there, I think people for that, 13.3, so it's this one. Okay, next one then, please. This is the symbols used to show an LDR. Well, let's go through them. This one's a diode. This is a fixed resistor. This one is a lamp. So this is the LDR here. Okay, you need to know your circuit symbols. There's a video I've got for circuit symbols as well. Okay, a student lifts a box with a force of 12 newtons, a distance of 7 meters. How much work do they do? So this is a memorize your equation. Do you remember work is force times distance? 12 is the force, 7 is the distance. You check here, you're in meters, because if you want an answer in joules, it needs to be in meters, and it comes out 12 times 7 is 84, so the answer is D. Next one, you can already see I've just paired these with some points here. Okay, yeah, can you just, if you're here and the live feed is nice and healthy and you can read the writing, can you just give me a thumbs up? That would be really awesome. The graph shows a relationship between the mass and weight on two different planets, okay? So that you're told, not the mass, you're told the weight of an object on planet X. So you use the graph, go along from the 3 newtons and down to the mass, okay? That's this line here. So this mass on planet Y is what you're asked for, is 2 newtons. So the answer is B. Okay? Thanks very much. I'm glad it's coming to you. It's all down through the 4G. What's the minimum number of forces that are acting on a compressed spring? This is the point that if there were only one force acting on this spring, then the thing would accelerate because you'd have a resultant force, okay? But that's not the case. There is a resultant force acting to change the shape, but not to accelerate it. So you need a minimum of 2 to stretch or compress something. So the answer is B. Which of these solid blocks has the smallest density? Now, I can't really see any way of doing this apart from remembering the equation for density. Density is mass over volume, and then going ahead and working out the densities. They've been a bit naughty though. They've told you an area and a height for each one, or an area and a length. So you have to work out the volume for each one. So in the calculator, the way I did this was just use the fraction button and do the mass 28. And you don't need to convert because they're all going to be in centimeters and grams. So you can work out densities in grams per centimeter cubed. And then on the bottom line, I did the area times by the height, and then just wrote out doing the exact same thing, but changing the mass and changing the areas. Okay, that was 0.5. Now, where people are going to get tricked up on something like this is because they're going to see this one as being the largest mass, and so they're just going to guess straight away that's going to be the largest density. But actually, this one turns out to be the smallest density when you do mass over volume. So be really careful. Make sure that you actually remember your equations so that you can calculate, so that you can compare. Okay, this one. Which sentence about static electricity is not correct? A charged object, so you just basically, with a question like this, you've got to go through and think, are they correct or not correct? A charged object exerts a force of attraction or repulsion on another charged object. Yeah, that sounds fine. So that is correct, and we're asked which one's not correct. If charges are the same on two objects, they attract each other. No, that's not right. The same repels. The like charge repels. Static electricity due to friction involves movement of electrons. Absolutely, that's something you need to kind of memorize. It's always talk about electrons moving. When a neutral object gains electrons, it becomes negative. Yeah, electrons are negative is the other thing you need to remember. So the answer here is B. Okay, a sealed bottle contains a gas. The bottle is heated and the pressure of the gas increases. How do the gas particles cause this increase in pressure? Now, my class has been talking about the difference between this one. Is it because they hit each other, or is it because they hit the can? Well, they definitely don't expand. One thing we like to check for when we mark GCSEs, we don't like to read the particles expand. It's not the average distance apart increases. That would actually be a decrease in pressure. So it's got to be one of these two. Is it because they hit each other or because they hit the can? Well, the pressure, the gas pressure is caused by hitting the container it's in, so it's got to really be D. Think about it, pressure is a force over an area. Think about what the area is. What is the area? Is the surfaces of the container it's in. Okay, next one. Plotting compasses are positioned at X and Y. This is a current carrying wire. So you just are asked, basically, you don't need to work out the direction using the right-hand grip rule. You just need to work out, compare the size and direction. So compared to Y, the strength and direction of X is. So make sure you are actually thinking about comparing X to Y. So this is X, this is Y. X is closer into the wire, so it's going to have a stronger magnetic field, so it's got to be C or D. Also, at this point, if the field, if it was up and the field was in this direction, therefore, then this would be pointing this direction, and this would be pointing in this direction, so it would be the opposite direction, so the answer is C. Well, that is the multiple choice sections. I hope that was useful. I'm just going to have a little pause to see what kind of chat Adam's been having with me. Yeah, Ahmed, I'm glad to be a helpmate. And what else? What a time-wasting question. Didn't see any other way of them working. Yeah, it is, yeah, but it's all about learning, can you do that equation and use it accurately? So yeah, I agree, it's an annoying question. Yeah, I'm glad this is helpful for you. It's all about decoding the question, okay? So even if you're an A-level thing, then the skills of decoding what you're actually asked to do is really still important. So I'm glad that's helpful. Okay, so this is a bit of a confusing one. Basically, we've got a drop height, okay, and the ball bounces like this, and they measure the horizontal distance. So this one largely is going to be about keeping your horizontals and your verticals separate, okay? Now, horizontal distance traveled, you see the steady increases of drop height, and now you're asked to complete the table by predicting the horizontal distance traveled by a ping pong ball at 80, right? So this number here, basically. And it's pretty tricky, I thought at first. There doesn't seem to be anything. Surely they're not asking us to work out, is it an x squared relationship, that type of thing. They're just actually going for, can you see a little pattern? And even though it's not a proportional pattern, 7, 6, 5, 4, 3, 2, it's got to be a 1, a gap of 1. So the answer is 35 in there. Okay, hope that makes sense. Use your kind of math skills in your physics papers as well. Next one, calculate the horizontal velocity. And that's where I always start reading questions, okay? If you want to know, I always look for the command word. I'm asked to calculate. What am I asked to calculate? Horizontal velocity. Then I'll have a little look through. So they've given me two things. They've given me the height and the horizontal distance. So I've got the equation. They've given me the equation. Now, actually, that means if they've given me the equation, then they're not testing the recall skill. So they're probably either testing a conversion of a unit or a rearrangement. You're asked to work out the horizontal velocity, so you've got to turn velocity and speed are similar, but velocity's just got direction, speed's scalar. But you just have to rearrange for speed equals distance over time, which actually you could have just memorised anyway. But anyway, there's a mark for that. Thank you very much. And then you're asked to work out, you just need to make sure you select the right distance. You ask for horizontal, so you want the horizontal distance, so 34 over 0.6. And then numbers in, do the calculation correctly, and you get this on the calculator, 56.6 recurring. We don't really want to see the recurring, so just do some rounding. 3 significant figures is fine, or 2 is actually fine as well. 56.7, not 56.6. Lastly, ask for a unit. Now in this case, you could have actually converted the whole thing, and you could have done 0.34 divided by 0.6 and got an answer in meters per second, okay, which would be 0.57 meters per second, and written all of that in here, and you'd have still got the right answers. But whatever you do, make sure you use coherent units. You can still work in centimeters per second. We tend to prefer meters per second, but they would never have penalised you. In fact, that was the answer they were expecting on this paper. Next one, a graph of the resistance of a thermistor against temperature. You should know this anyway. And all they're looking for here is a description. So it should really say describe what happens to the resistance of the thermistor as the temperature increases. They're just looking for higher temperature, lower resistance. Not looking for any kind of mention of the shape of that. You can just see these are the higher temperatures, these are the lower resistances. Okay, so keep it simple. If they're asking you for a simple 1 marker, it's probably that. If it was 2 mark, then they might be asking you to go into more detail. Might be saying it's steeper at first, shallower later. But this is only 1 mark describe. Okay, so just asking for something simple. Fixed resistor is 5 ohms. All right, what we have to do with that? Let's have a little look. You're asked to work out the power. Now you've been given in this case the equation, so it is one that you need to memorise, but you're given it this time, so well, okay, are they testing anything else? Well, no, because it's only worth 2 marks. So what they're actually testing is they're testing substituting in, and they're testing calculating the answer. So you've got 2 amps, and you're told to calculate the power dissipated in the resistor. So we're not interested in the whole circuit, we're just after the power dissipated in the resistor. Now, the fixed resistor is 5 ohms. We're not asked about the thermistor, so we can ignore that. We're not told anything about the resistance of the thermistor, apart from the earlier graph with no numbers on it. But we're asked to figure out the power dissipated in the resistor. So it just becomes 2 squared times 5 gives you 20 watts, I hear you ask? Yep, correct, 20 watts. Right, so there's enough for substituting correctly and for calculating the final answer. You've got to be careful with that one, obviously, to make sure that you hit that squared button. Easy peasy. All right, okay, next one. A fish is swimming upwards, or sorry, swimming forwards, and the forward force is labelled on the diagram. So they've given us this thrust force, and you're asked to draw and label the 3 other forces. Okay, so draw and label 3 other forces. You see it's worth 3 marks. Whenever you get asked about a Freebody diagram, the first thing you can always put, unless you're told it's in outer space, you can put weight on, okay? So first thing to do is put the weight on, and actually that was easy, you got a mark. You can write just W for weight, we all understand, us examiners, or you can write the word weight, okay? Also, it is probably, well, in fact, it's swimming forwards, okay? You don't have to talk about the water pressure, which is in all directions, but you do have to talk about the up thrust. Okay, now if it's swimming forwards, at constant velocity, it's not increasing, then there's an up thrust upwards, and that arrow should be an equal length to the weight. Okay, but in fact, I think in this case, they're just looking for the direction and the label. Okay, and then lastly, well, it's swimming forwards, that means it's going against the kind of water. That means there's a water resistance, which we just call a drag. Okay, a viscous drag. So there we go, drag is fine there. So that was thinking really 3 forces. You can at least get 1 straight away because you always put a weight on. You think about it being balanced, it's underwater, so there's an up thrust, it's not going through. It's swimming at a constant velocity, so the forward force would be the drag, okay? It would be equal to the drag, easy peasy. Okay, this time again, let's have a little look. Calculate the power of the fish, and they've given us an equation. They've given us an equation, but it's not in the form power equals. So the first mark is actually for rearranging. So if you look, calculate the power, you can see the equation. Can you rearrange that to give power as work done over time? Mark for that. Then you have to figure out the work done. Okay, work done is how much energy has been transferred mechanically, essentially. And you need to remember we don't use kilojoules, we use straight joules. So there's actually a mark for converting into joules. So make sure if you see that, if you see kilojoules, get rid of it. Even if you can't do anything else, you've still got a mark. Okay, And then lastly, for subbing in correctly, and finally for having 45 watts again. Okay, next. And the last one I'm going to go through in this little session here, and then I'll have a little look if there's any comments. Do think about if you want me to go through later. I'll do a really quick question and answer at the end of this, but then I'm back in a short amount of time to do some more questions as well. So a security light is designed to switch on automatically when it becomes dark. Part of the circuit for a security light contains a battery, a light-dependent resistor. That's this one. Okay, you can see the arrows indicate the light-dependent resistor. Part of the circuit, sorry, so that. And a 2000 ohm resistor, okay, so 6 volts, okay, across 2 resistors in series. So this is what you call a potential divider. So what you need to do is recognize potential divider, recognize you've been told in a bright light the voltage across 2000 ohm resistor is 4 volts, okay, so in other words there's 4 volts across here, okay. So there's 6 volts in total, and you need to remember for circuits, and this is something I'm going to go through later on as well, circuit problems, is 6 volts, 4 dissipated here, so that only leaves 2 dissipated for that one. So the answer was just 2. Okay, have a little think about it. It's only worth 1 mark, so it's not going to be a complicated calculation. It's just going to be for subtracting 4 from 6. Lastly, calculate the current in the 2000 ohm resistor. So now that you know the voltage, or in fact you're told the voltage across the 2000 ohm resistor is 4, you can just use V equals IR. So there's a mark here for just remembering and recognizing you need to use Ohm's law in this case. Okay, there's a mark for rearranging and having the numbers subbed in, 4 over 2000. And there's a mark for the answer with a correct unit. Now, I'll just say here, you could have either of these. In fact, the calculator, when I did this, 4 over 2000, it comes up with the number in standard form. That would be fine. Recognize that's in amps, okay, and that would be fine. If you put 2 times 10 to the minus 3 amps down here, then that is correct, and you get all 4 marks. But if you want to, you can convert into milliamps just for kicks. It is the kind of thing we would do if we've got a tiny little current like that. We would be talking about it in milliamps because it's just more useful to give whole numbers of milliamps and understand how to use our prefixes. A milli is a times 10 to the minus 3. All right, I hope that was helpful to you all. Okay, just to remind you again, if you're an A-level student, then go ahead and make sure that you tune into A-level Physics Online this evening at 5 o'clock. Lewis is going to be doing another live session. I'm going to be back for you GCSE students just in about 20, 25, 30 minutes or something like that. I'm going to go through some higher tier questions. Okay, so you can come back and have a little look at that. And then after that, I'll probably go away for another couple of minutes as well, and then I'll come back and do a little bit of a Q&A. And tomorrow I'm going to go through some more higher tier questions for GCSE, and I'm going to do a Q&A as well because your exam is on Wednesday. Thank you very much, Adam. It's been a pleasure spending time with you. Thanks for watching. Any other questions? Oh, there's one more thing I wanted to say to you. It's you probably won't have time to get the paperback ready for tomorrow, okay, or for Wednesday rather, but you can get this from a Kindle, okay, and there's a link down in the description for this. Those are links to other GCSE playlists. I'll make sure that my next video has got a link to the AQA GCSE playlist that I've done for paper 1 as well, and yeah, thank you. And also there's there's my OCR Gateway Paper 1 playlist as well that you can watch at your leisure. You might want to go ahead and do that. Might already be in the description actually, but it's certainly in most of my descriptions because I always put those links in there, or just on my channel page. Yeah, somebody asked, is it only for OCR? The questions I've got are from OCR, but if you've got a question that's not on OCR Paper 1, then by all means ask it, and I'll go through that in my live Q&A later on. Certainly it'd be useful. The topics aren't exactly the same, but I think all GCSEs have at least some mechanics in paper 1. I don't know if they all have electricity, but the main topics will be mechanics, electricity, also models of the atom and pressure, things like that, a particle model, and lastly magnetism. So if that makes sense for you, if that's useful to you, or at least half of that's useful to you, then stay tuned and I'll catch you in about 25 minutes.